Chapter 3. Chapter 3 has a lot to do with parallel and perpendicular lines, and you're going to also see that Chapter 3 is very similar to what we have done in algebra. Okay, so some of the topics that you see on here about parallel lines, perpendicular lines, things like that, equations, a lot of these are things that we've done before. But you will see proofs, 2 sections of proofs coming back up in this chapter as well, okay? So in the first lesson, they're really trying to just get you to have a good understanding of the definitions about different pairs of lines, and when these types of lines intersect, what kind of angles are formed. So let's start out with the different types of lines. So if you look here, you'll kind of notice there's 5 different types of lines listed. Now I'm not going to give you the book's definition, I'm just going to kind of give you a generic definition. And if we were together, I would be kind of asking you, but since I'm alone, I have to write it myself. So in my mind, parallel lines are lines that never cross. Or you can use the word intersect, whatever you feel more comfortable with. So if you just kind of quickly think about parallel lines. So I have 2 lines here, A and B. Oftentimes we'll use this symbol where they're just 2 slanted lines to indicate parallel. And another thing is you'll often see these extra little arrows that are drawn on the lines to represent that those are parallel. Now perpendicular lines, parallel planes. I was getting ahead of myself here. So parallel planes. Parallel planes are also planes that never cross. Now this is extremely difficult to do or to draw. So oftentimes what you'll see is you'll just see one plane. So remember, we kind of draw it as a slanted parallelogram, and then you'll label it like T or whatever letter you want to use. And then off to the side, you'll just see that they'll draw another parallelogram, and then you label it something different. So again, if you notice, that would be an example of parallel planes, because planes go on forever, so it's really difficult to draw on a 2-dimensional surface. Okay, I was getting ahead of myself. Perpendicular lines. Perpendicular lines are lines that cross to form a 90-degree angle. Okay, so oftentimes what you'll see is this right angle mark, kind of this little box right there. And let's say we call this A and B. We usually use the symbol, which is an upside down T. That's the kind of the shorthand for perpendicular, and you'll see that's the shorthand for parallel. All right, skew lines. Skew lines is a difficult concept because it's really a 3-dimensional. So you have to really kind of think of this as a 3-dimensional idea. So it's lines that are not parallel and do not intersect. And do not intersect. But they are also coplanar. So, they're not coplanar. They're also not coplanar. That would be really difficult to be in the same plane. So the easiest way, it's kind of hard to draw. The easiest way to think about it is like if these were 2 lines, one would have to be like higher than the other. And I know through the document camera you might not be able to see that, but if you look here, my pens are actually not crossing. So I have one kind of in a lower plane and one kind of in an upper plane. So they're basically in separate contained planes. So they're not coplanar. So again, skew planes, the easiest kind of example to give you is if you look at like a cube. So notice right here, it'll talk about the word skew, but before we get to that one, let's say you pick AB. You would want something that is not parallel and does not intersect. So maybe you could go down here and you could say like FG, because this stops, or even if it were to continue on, it would never cross F to G. So that's what you want to think about when you think about skew, is kind of try to really get your mind around a 3-dimensional object. All right, and then a transversal is a line that intersects two or more lines. So let's just say we take line A, okay, and I'm going to use a different color here. Let's call this my transversal, so this is T. Notice it's going to intersect A, but then I need another line. Let's call this B. So if I don't draw the second line in, then this is just two intersecting lines. But once I draw the second line in, now this becomes a transversal. If these lines go on forever, technically any one of these is a transversal. So lots of times, even though lines go on forever by definition, a lot of times what we try to do is we try to only envision what is pictured, because then it's almost like, well, every line's a transversal. So we try to kind of just stick to it as what we can see, okay? So I guess really there's only 4 types of lines up here because this one is about planes. I just quickly counted them, but there's really parallel, perpendicular, skew, and transversal. So there's like 4 types of lines. Now, these postulates. We don't really use these postulates a lot, but they're good to help you kind of just understand the general idea sometimes of what's going on. So I wouldn't be overly concerned with these, but I think we should still go through them. It says parallel postulate. If a point is not on a line, so if I have a point here and it's not on the line, like that, so we can just call this like line L, then there's exactly one line through that point. So there's only one line I could draw through this point that is parallel. There's lots of lines I could draw through this point. I could draw lots of them. You know, I can draw lots of them. But there's only one that's parallel. So if I could draw this as close to parallel as I can, there's only one that's parallel. Which, remember, postulates are kind of like the fundamental building blocks. There are things that we assume to be true and that we can build from. All right, the second one, it's called the perpendicular postulate. If there is a line, and it really doesn't matter what angle you draw it at, I'm just kind of drawing it. So if there's a line and a point not on the line, so I'm going to put my point here again, it says then there's exactly one line through the point. So only one line through this. Now I know there's lots of lines, but there's only one line through this that is perpendicular to the given line. So there's only one line I can draw that would be perpendicular, which is true. Because if lines are straight and they can't bend, how else would I do it? Okay, so again, these postulates are just good for you to just get through the general idea so that when we get to something more difficult that we do need in a proof, that you're understanding how they work, okay? So if we turn to the next page, we have 9 questions here that are really just asking you to kind of go through the vocabulary and answer them. So how about I'll do the first maybe 2 with you, and then I'll have you pause it and you can try it on your own. So on number 1, it says the lines parallel to CD and contain point A. So I have to be parallel, but I have to contain A. So that only makes one line, which would be AB. And remember, because this is a line, you could reverse the letters, but you would want to make sure you have the 2 letters with the line, the arrowhead, the symbol above it. Okay? All right, number 2. It says lines, so it could be more than one, but it might not be. Lines skew to CD and contain point A. Now we got to be very careful. We cannot be parallel, so we cannot be AB. We cannot intersect, so we cannot be AD, but we could be AH or AG because they're in different planes. They're not parallel and they would not cross. So we would need AH and AG. Those would be our 2. So why don't you stop the video here, pause it, and why don't you try the remaining, 7 questions and see if you can, see how you do. All right, hopefully you paused it. We have a line perpendicular, lines that are perpendicular to CD. so line perpendicular to CD, and it contains point A, so it'd have to be AD. All right, how about a plane parallel to plane EFG, which is this bottom plane? It has to be parallel, and it contains point A. Well, honestly, they could have just said parallel because the only plane that's parallel is this top one. Now remember, when you name a plane, you get to pick any three of the four. So A, B, C, or D. Pick any three. So I'm just going to do A, B, C because it's alphabetical. All right, number 5. Name the lines through point F, so through point F, that appear to be skew to EH. So here's EH, and it wants it to be skew. So it cannot be FG because that's parallel. It cannot be FE because it would intersect. So it has to be FC. Again, as you can see in these 5 examples, they're not going to ask you to define the word skew. They're not going to ask you to define the word parallel, but they're going to give you some type of a picture, and they're going to ask you to use the vocabulary words to answer the question. So it's not crucial that you look up the book's definition of these, but you have to understand the difference between, say, parallel to skew or perpendicular to transversal. That's what's more important. Okay, the second one, or the second set here, is just trying to give you a different diagram, and 2, something that's more realistic. Not that cubes aren't, but how often do you look at a cube and have it be labeled? So this is just giving you almost like a city map. So it says name a pair of parallel lines. So when I look through this, the big thing I'm looking for is these markings, okay? So I'm looking for these 2 lines right here. So I'm going to go with DM, and I'm going to go with EF. Now remember, it does say line, even though this looks like it ends. If it wants lines, then we've got to give the right symbols. All right, name a pair of perpendicular lines. So again, I'm looking for that perpendicular symbol right there. So same thing, I'm going to go with this bottom line here. How about I go with DA and BM? That's where that 90-degree angle is formed. Now you could use slightly different letters than mine, which is okay. Just make sure it's the same line. All right, now they're just asking me a question. Is FE parallel to EC? I would definitely say no. Now, I'm not a huge one on explaining, but if I was to be looking at this, EF and EC, I would say no, like maybe because they intersect at E. Like, how can you be parallel if you intersect? So just give a quick explanation. All right, it says, can you conclude CD is perpendicular to MD? Now, it surely looks like they might be perpendicular, but I'd have to say no. And the reason why I would have to say no is because there is no 90-degree mark on the diagram. We have to be for sure. Maybe this is 88 degrees, or maybe it's 91 degrees. We need this marking. We need some more information to know for sure. Okay, so once again, from the front side of your page, they're going to ask you kind of about different types of lines. Notice they switched to symbols here instead of the vocabulary word, but you're supposed to understand what that symbol means. Now, the last part of this lesson is what happens when the lines come together to form angles. So you should have already done these in middle school, but just to kind of quickly review, corresponding angles are going to be when they're on the same side, and one is interior and one is exterior. Now, sometimes I get asked about interior versus exterior, okay? If this is my transversal, the interior is between the 2 lines. So this is my interior, okay? So then out here, this would be my exterior. So notice 6 is interior and 2 is exterior. So that's called corresponding. Then I call it 2 alternates, and I do 2 corresponding. So we're going to hear me talk about that in a minute. But alternates. You can either be an alternate interior or you can be an alternate exterior. So if you're an alternate interior, notice the word alternate. You're on opposite sides of the line, but you're between the 2 non-transversal. So that's alternate interior. If you go down to this picture, notice you're still on opposite sides of the transversal, but notice they're both exterior. So I'm shading the interior again, so you can see how they're both exterior. Now, if these were on the same side, so if you would have had a picture that kind of looked like this, 1 and 8, I call those same side exterior angles. Now you're going to notice that that is not listed on here because the authors of Big Idea like to use the word consecutive. So there's no way to be consecutive exterior. So if you look at this, do you see how they're right, like boom, boom, they go right one then the other. That's what they call consecutive. So they call this consecutive interior because see how they're both interior. Our old book uses the word same side interior. So I will tell you this, you'll never see both as a multiple choice option, but just kind of know when you hear the word same side and when you hear the word consecutive that it means the same thing. But there would be no way to be consecutive exteriors because consecutive would have to be one and then the next one. So that would not, you couldn't have that. So your book leaves this one off, but it's very commonly used in the field of mathematics, so I think I would go ahead and write it down. So we've got on the same side, and notice again, this is my interior. So these would be same side exterior. So I think of this as 5 different kind of like angle pairs or angle types that you can have, okay? So if we go down to this next section, notice we've got kind of a basic picture and then they get a little bit bigger down below here, okay? On this basic one, they want you to list all the type of angles that exist. So if we look at number 10, okay, we're asked to list all of the corresponding. So again, if I was with you, I would ask you, but since I'm not, I'm going to start with 1 because it comes first. So 1 goes to 5, okay? So we'd say angle 1 and angle 5. Those are corresponding. You could also do 2. 2 would go to 6. My pencil lead here. Come out of lead there. Okay, here we go. Angle 2 and angle 6. Notice I'm just kind of staying on the top side. Now I would go to the next one. 3 would go to 7. And you should notice with corresponding, they have to be on the same side. One is interior, one is exterior. Now notice, with this diagram, this is my transversal. So this would be my interior. Okay, so 3 is my exterior, 7 is my interior. All right, I've got one more set. I've got 4 is interior, and it goes to 8 is exterior. So those would be the corresponding from this picture. All right, let's do alternate interior. So notice they're both interior, so you pick one of these 4, and if I was there with you, or we were together, I would ask you, but I'm just going to go with 2 because it's the lowest one. So if I pick 2, an alternate would be 7. So 2 and 7. Then if I were to pick 4, 4 would be an alternate to 5. Now, if you notice, there's only 2 of these. There's not as many options as we had with corresponding, but that's okay. All right, alternate exterior. So now this is our interior. We've got to pick an exterior. So let's say we pick angle 1. 1 is going to go with 8. Because remember, they have to be on opposite sides. So then let's choose 3. So if we choose 3, 3 would go to 6. And those are only alternate exteriors. Now, notice on 13, it says consecutive. If you want to change this and think of it as same side, I'm okay with that. I'm just telling you that the author of the Big Ideas book uses the word consecutive. So if we're doing consecutive interior, let's say we start with 2. We have to do same side of the transversal. Now don't tell me 2 and 4 because those are a linear pair. So we want to go 2 to 5. Then we'd also do the other side. So now we would do 4, and 4 would go to 7. Now we don't have it listed on here because, again, the word consecutive. But if you wanted to do same side exterior, you could do that category as well. So I'll just quick run through that. Let's say I pick angle 1. So angle 1, if it's the same side, would be angle 6. And if I pick angle 3, 3 has to be on the same side, so it would be angle 8. And these are just different ways to name them. Now remember, you can still have vertical. So 6 to 7 would still be vertical, where 6 to 8 would be a linear pair. So you can still have verticals and you can still have linear pairs. Those are also still angle pairs. They're just from a different chapter. All right, now if you look at the bottom, notice they've just given us a little bit larger of a picture, and they've picked out the angles and they want us to name them. It's very common to use abbreviations for these. So for corresponding, you'll often see me put CA. For alternate interior, you'll often hear me or write down or see me write down AIA. For alternate exterior, it's AEA. Now you got to be careful. If you're going to use consecutive, you can't, I guess you could put CIA like that. But again, CIA is kind of like a police officer thing. So I don't really know a good one for this one with the word consecutive. I just use same side. So I call it SSIA for same side interior angles. So if I'm going to do same side exterior, then I just do SSEA like that. So again, just 20 years of experience just kind of telling you what I see sometimes in math is they like to switch up one kind of little word. So it's up to you. But why don't you pause the video here and why don't you try these 6? This is our last little diagram. So try these and see if you can come up with the correct answer. Okay, hopefully you've tried them. 3 and 12 are same side interior. 6 and 8, that's an old one. Those are vertical. That's an old one. 15 and 9 are alternate exterior angles. 7 and 13 are alternate interior. 10 and 14 are corresponding. And 5 and 14 are same side exterior angles. And that concludes the first lesson in chapter 3.